So this is my second go round with UID mapping, and what we are trying to do with the support of the OpenSFS is implement UID mapping, which I had done in, as Thomas said, in 1.6 and 1.8, and bring it into the 2 Lustre, as well as add a shared key GSS API mechanism that Andy will talk about as an alternative to Kerberos, rather than, we tend to think about it as an SSH kind of authentication and encryption mechanism, where it doesn't depend on a third party. The motivation behind doing this, the past 2 speakers have gone over completely, and I'm not sure that I can add much to this, except that when we started doing Lustre, we found that we had to talk with other organizations within Indiana University that didn't share the same UID and UID space. So we had to come up with a way to map them if they wanted to use our central resources to do their work. We went to the OpenSFS after we completed 1.8 and said we wanted to bring this into 2.0, the 2 Lustre 2 system, and what we wanted to do is make it part of Lustre rather than a bolted add-on as we had done before. We wanted to make it supported. We wanted to provide a common set of tools for configuration. They were good enough to support us, and we divided, well, my part of the project, the UID GID mapping, is divided into 3 parts. The first part, UID GID management module, we call them node maps. It's part 1, UID GID mapping in the MDT and OST to actually do the mapping of requests and responses to the canonical set, and synchronization of the map from the management node, the MGS, to the MDT and the OSTs via LNAD, so that you don't get a file system that's out of sync. The node map features, again, this is something that has been gone over. We define node maps as an NID range and the ID maps that are associated with them, the UID and the GID maps, and also flags determining how those ID mappings are respected, whether or not we allow UID 0 to be unsquashed, whether or not we trust UIDs or GIDs of the incoming requests, because some systems are within our UID space and some systems are out. And also what security flavor that a node will require, a node mapper will require. So I came up with a structure that lives in the node map kernel module, and this is the basic layout. We have a human readable name, a numeric ID, and then the unsquashed UID GID. This sort of supersedes the UID GID squashing that is currently available, but certainly doesn't replace it. Behavior flags, trusted administration, and then red-black trees of the ranges that comprise the node map, as well as a set of trees that do the forward and reverse mapping, and also a list of the export structures of the clients that have connected and that are contained within that node map. And the reason we can keep a list of those structures is that because when a client connects, we do the lookup then. We try and minimize the number of lookups that we have to do in the tree because we know it's an expensive operation. We want to minimize the amount of time. And this comes from having run this system in production for the last 5 years, is we've run into nearly every problem that that is available in this space. And our motivation behind rebuilding this is to try and fix those problems and make it easier for someone other than the guy who wrote it to use it. So a client connects to a Lustre server. That client is then looked up in the node map list based on its NID, and then it's classified, and a pointer to that node map structure is attached to the client export structure in the server, so that every time a request comes in from that client, we already have the export structure, we already have the maps, there's no looking up, they're right there. So we have the file system request lifecycle where the client is requested, and then the RPC is unpacked. Once the RPC is unpacked, then we can do the mapping and perform the file system operation. Similarly, when the operation is done, when it's complete, we do the reverse mapping and pack the response. This is all common sense, but I thought it should be explicitly mentioned how this is happening. And then the response is sent back to the client. The way we are handling the distribution is all of our mapping, the canonical set of the maps, are stored on the management node, whether or not it's running on the same hardware as your primary MDT or not, it doesn't matter. That is where it's written, and the maps are stored as index files because, well, I'll get to that in a second. Not all configurations are valid for every use. And we are doing something akin to imperative recovery, where when the map changes on the MGS, deltas are sent to the other nodes, the MDS, the OSSs, so that if you have a very large map, and we fully expect there to be very large maps, and we're designing it to handle large sizes, large numbers of node maps with large numbers of UIDs and GIDs in them, you're not sending everything around. Now, as part of the OpenSFS and being supported, we have a dev pack, and part of this talk is about the process that we've had to go through as a project funded by the OpenSFS and our experiences doing that. The Development Project Approval Committee is comprised of volunteers from the OpenSFS community, and they review the project, improve the completion of milestones, and basically provide us with enough feedback from the representative of the community so that we aren't, driving off into left field and only serving our own needs while we're writing this. And we've had more than our set of challenges while we've done this, and I can take full blame for some of them. My most grievous problem is submitting manageable commits. I tended to submit things that were too large, and I didn't think about what I was doing to my poor code reviewers. So they very nicely informed me that I needed to knock that off. And I have subsequently knocked it off and submitted code requests that make a little more sense for the reviewer. Beyond that, the code style that's written down, and I am very happy for the code guide that is available from Intel. The code style is more than what's written down, and most of my code reviews have come back with basically style problems where I may have followed the letter of the code guide, but there is some of the spirit that I missed. So that's been in there, and all of that comes down to expecting the unexpected. I was expecting my technical approach to be hammered. I was expecting lots of things, but I was not expecting those problems. We are the first OpenSFS project that isn't Intel, and in doing that, we're sort of plowing a new area here. Let me check the time. When we originally submitted design documents to OpenSFS, there were no templates available, so we copied what other people had done. And that may not have been as big a problem for us as it was for our dev pack, because they didn't really have as much of a criteria on which to judge what we were putting forward. Other questions there are on the Git server, there's Lustre release and Lustre dev. Figuring out where you should branch is actually more of an art, and it depends on where everybody else is and what they're trying to do. And then we had difficulties with finding a place to put our code so that it was easy enough for everyone to get to, and comment on and make the sort of reviews that they wanted. That said, we have very tired reviewers. Our reviewers are great. Every word the reviewer gives you in a project like this is gold. You want everything out of this because they are doing nothing but taking their time in making your project better. And there's nothing, I cannot thank them enough. That being said, we've had some successes. Our scope statement, solution architecture, and high-level architecture were approved by the OpenSFS. And the UID GID management module has been committed, and a first set of code reviews has been done, and I've submitted for a second set of code reviews, and those take a while because, as I said, code reviewers, everything they do is gold, but they do it on a volunteer basis. So I'm not waiting around so much, so I've started work on the second part of the project, which is actually the mapping, and that's territory I've actually been in more with the 1.6 and 1.8 code bases, so that will be easier. And again, I'm thanking the reviewers because everything they said they give to me is gold. I want to thank the OpenSFS board for supporting this work. I'd like to thank the DevPack, Nathan Ruttman from Xyrotex, Alex, Ned Bass, I'm Ken Hornstein. I'm sure I'm forgetting other people. Andre, oh God, yeah. Every word that man says is gold about your code. And several others, as well as my manager, Steve Sims, who constantly reminds me of everything I forget. which is more than I would like to do. And it's time for me to be done. Thank you very much, and I'll be around to answer questions.